Hey there, this is the first video of your Chapter 4 review for the exam. I wanted to start out with a video about filtration. I wanted to start by discussing the barriers, some principles for filtration and the criteria of filtration before we get into regulation of GFR and so on. So I assumed that you knew the anatomy of the nephron. If you don't, go back and review it. It's always good to know each point of the nephron. You should know the difference between the cortical and juxtamedullary nephrons, which one is more predominant in humans, and what they're used for, as well as the osmolarity differences for each. So let's jump into this filtration. We're going to talk about the glomerulus and how the filtrate passes through to enter into the proximal convoluted tubule. So I have the afferent arteriole drawn here. As the filtrate enters, it'll first pass through the fenestrate epithelium. The fenestrate epithelium has small pores that are 70 nanometers in diameter. It also has charged glycoproteins that will resist or filter against negatively charged proteins and other particles in the filtrate. So once it passes through the fenestrate epithelium, the second barrier is the basement membrane. The basement membrane is collagen. It's a porous matrix full of negatively charged proteins. This is the most important barrier in filtration. The one that you should know is the most important. So here it will filter against negatively charged particles. It also has a size that it factors against, that it will filter against, before entering or passing through the podocytes, which is your last barrier. Podocytes are foot-like projections that come together and form filtration slits. These filtration slits will filter against size and charge as well. I have a graph drawn here that will help you understand some principles of filtration. So this top line here is the line for a cation, the filterability of it. So here on the x-axis I have size drawn, on the y-axis filterability. So it's easier to filter the higher you go, and the larger size is to the right. So a larger cation will filter slower, has to filter through the fenestrate epithelium, as well as these two membranes. So smaller particles will filter easier. Small cations will filter the easiest. Here in the middle is a neutral particle and its filtration line. The most difficult to filter are the anions. Small or large, they're charged, so we have a lot of negative charge in each of these barriers here that will be able to filter against negatively charged particles. Criteria for filtration, we have two main criteria that you should know. You should know that we filter against size and charge. Those are the two things that we look for. Really big things don't filter well. Really negatively charged things don't filter well either. So we should never see red blood cells in the urine, and we should not see many proteins either. I also want to mention mesangial cells that line the capillaries, the glomerular capillaries, as well as the afferent and efferent arterioles. They can contract and effectively change our GFR. For barriers, this is the thing that you should know most about.